I'm Shalini V, working as Assistant Professor of Physics. In this video, I will discuss the topic for the session 33 for B.Sc first semester. The topic of this session is Review of Elastic Behavior of Solids in General. So before that one, we have to know what is an elasticity, what are perfectly elastic bodies and perfectly plastic bodies. So all bodies can more or less they get deformed by suitable applied forces. The simplest cases of deformation are change in length, change in volume but no change in shape or form of the body with no change in its volume. In all these three cases, the body is said to be strained or it is said to be deformed. And when the deforming forces are removed, the body it tends to recover to its original condition. And this property of a material to regain its original condition on removal of deforming forces is called elasticity. Then what are perfectly elastic bodies and perfectly plastic bodies? So the bodies which can recover completely their original condition on removal of the deforming forces are called as perfectly elastic bodies. Whereas the bodies which do not show any tendency to recover their original condition on removal of the deforming forces are called as perfectly plastic bodies. So there are no perfectly elastic or plastic bodies, but the nearest approach to a perfectly elastic body is quartz fiber and a perfectly plastic body is putty. Thus, difference between the perfectly elastic and perfectly plastic bodies, they differ only in the degrees of their elastic property, and a body is more elastic or plastic when compared to the others. Then we shall consider the elastic behaviors of solids in general, that is some peculiar triads. First one is elastic after effect. So the few solids like quartz, phosphor, bronze, silver and gold, they come back to their original condition almost immediately after the deforming force is removed. But solids in general, however, they take appreciable time to come back to their original condition after removing the deforming force. This delay in recovering back the original condition on removal of the deforming force is called as elastic after effect. So the bodies, in general, all the solids, they take a certain time to come back to the original condition on removal of the deforming force. And this is nothing but called as an elastic after effect. So glass exhibits this effect to a high degree. So then second one is elastic hysteresis. So this elastic hysteresis, it is a consequence of elastic after effect. So here in this elastic, that is elastic hysteresis, the strain it persists, that means exists even when the stress is removed. So even when the stress is removed from the material, the strain exists, and that is the strain lags behind the stress. As a result, suppose if a material is subjected to a full cycle of increasing, first increasing of the load and decreasing of the load, it is found that the strain is found to be greater for the same values of the stress when it is being unloaded and than when it is loaded. So if we observe that strain value, the value will be different for the same stress while loading and while unloading. So this lag between stress and strain is called as an elastic hysteresis. This phenomena is similar in its implication to a familiar magnetic hysteresis. So thus material which show little or no elastic after effect also show no elastic hysteresis. So then the third one is elastic fatigue. So Lord Kelvin, while investigating the rate of decay of torsional vibration of wires, that the vibration die away much faster in the case of uh, material kept vibrating continuously for time than in that of a fresh wire. The same thing happens to any elastic body if it is subjected to an alternating strain. The continuously vibrating wire gets tired or fatigued, as it were, and finds it difficult to continue vibrating. So, Kelvin expressed this by the term called as elastic fatigue. Then, in case of the effect of the elasticity on hammering and rolling on a material. So during the operations like hammering and rolling, so in hammering and rolling, there will be a breakup of the crystal grains of a material into smaller units occurs, and this hammering and rolling of a material will makes the elastic prop makes strength increases the elastic property of the material. Whereas if we consider the process of operation of an annealing, so in annealing it will so in annealing will the crystal grains or will orient into one particular direction. In that annealing, during the annealing process, it will increase the not increase, it will decrease the elastic property, or it will strengthen the plastic properties. So the hammering and rolling will increase the elastic property of a material, but whereas the annealing will weaken the elastic property or it will strengthen the plastic properties. Then the next one, effect of addition of impurities on the elastic property. So the addition of impurities to a material will affect the elastic properties of the metal. So addition of carbon to iron or potassium to gold, they will strengthen the elastic property of both the iron and gold. But the effect of temperature on the elastic properties, so any change in the temperature will affect the elastic property of the material. So a rise in temperature will result in a weakening of the elastic properties. So with the rise in temperature, the elastic property decreases, but whereas the decrease in the temperature will increase the elastic property. So thus carbon, which is a highly elastic at the ordinary temperature, it becomes plastic when heated, and that heating can be done by passing a current through the carbon. So thus any increase in temperature will decrease the elastic property, and decrease in temperature will increase the elastic property. So these are the books which have referred for this topic. Thank you.